So, hello students, good evening to all. And today we are going to discuss some questions related to biomolecules lesson. Okay, so let's go with the topic. And here in this lesson, we are going to deal with some six types of biomolecules, which are carbohydrates. We are going to discuss about the carbohydrates, and proteins. And the third one is enzymes. And the fourth biomolecule is vitamins, and fifth is nucleic acids, and the sixth one is hormones. Okay, sixth is hormones. So these six are the biomolecules which are included here in this lesson, and we are going to see questions related to these six topics. Got it? And moving on to the first question for today's session, it is on your screen. You can see the question on the screen. So given below are two statements. So statement one says that, yes, Samruti, good evening. Yeah, statement one says that a unit formed by the attachment of a base to one prime position of sugar is known as nucleoside. Okay. And statement two says that when nucleoside is linked to phosphorus acid at 5 prime position of sugar moiety, we get nucleotide. Okay. So we have to choose the correct answer from the options given below. So I'll give you 15 to 30 seconds to solve this question. You try for it and let me know the answer in the chat box. Okay. Let me know the answer in the chat box. So Samruti, I am visible and audible to you, right? Just can you reply me in the chat box whether am I audible and visible to you or not? Yes. Okay. Okay. Just let me know the answer in the chat box. Yes, Samruti. Thank you so much. And what is the answer for this question? Option B. Statement 1 is true, but statement 2 is false. Yes, you are correct. Statement 1 is true and statement 2 is false. Why? Statement 2 is false. Why statement 2 is false? You can see the nucleoside on the screen here. So here the base is attached to the 1 prime position of the sugar molecule. And in case of nucleotide, if you see, so the nucleoside, this is the nucleoside part, and this nucleoside part is linked to phosphoric acid. It is not phosphorus acid. So what is the name of the acid? The sugar molecule. The nucleoside is linked with phosphoric acid. Okay. So that's why the second statement is wrong. So statement 1 is true and statement 2 is false is the correct answer. Yes, good. So coming to the second question, the incorrect statement about the denaturation of proteins is. So the incorrect statement about the denaturation of proteins is. Try to solve this and let me know the answer in the chat box. I'm coiling of the helical structure takes place, and it results due to the change of temperature or pH, or it results in loss of biological activity of protein. A protein is formed from amino acids linked by peptide bonds. So, which is the incorrect statement about denaturation of protein? We can denaturate a protein by doing physical change or chemical change, right? So physical change in the sense we can increase the temperature. We can increase the temperature. Option D, yes, correct. You are correct. Good. So physical change is increasing the temperature and chemical change is changing the pH. So by doing so, what we are doing, we are denaturating the protein. That is, the protein loses its biological activity and the helix gets uncoiled. Globules are unfolded and helix gets uncoiled. Okay. So these are the things happening during the denaturation of protein. So you can see option A, B, and C. So the first three options involves all the statements which I have told now. And option D is the only incorrect statement where a protein is formed from amino acids linked by peptide bonds is wrong. Actually, those bonds are broken down. No? So that is the incorrect statement. They are not formed, they are broken down. So option D is the correct answer for this question. Good. So I'll move on to question number 3. So you can see a reaction on the slide and you have to find out the products formed in the above reaction. We have to find out the products formed in the above reaction. Okay. We have to find out whether two optically active products are formed and only one optically active and one meso product. Third is two optically inactive products and one optically inactive and one meso. So which will be the correct answer for this question? So glyceraldehyde, D plus glyceraldehyde is taken as the reactant and it is treated with HCN and then on hydrolysis, third with nitric acid. So take some seconds and try to find out the answer first. So what would be the correct answer? Shall we do it? Shall we do this? So let me show you the solution. So you can see the reactions on the slide. So this is your glyceraldehyde. This is our glyceraldehyde. It reacts with H2O. Which one? Which one reacts with H2O you are saying? Yeah. So this is the glyceraldehyde on your screen, which is a 3-carbon containing system. Yeah, first aldehyde reacts with HCN. Then only it undergoes acid hydrolysis. Okay. It is not actually H2O, it is acidic hydrolysis. Got it? Yes. So these are the 3-carbon containing system. And here is our aldehyde group present, in which we have so H, C, OH, and here we have CH2OH, and to this carbon only we have the C double bond OH, right? So how to add this HCN to the system? You have to break one of the double bond and add hydrogen to oxygen and C to carbon. So what we get? So the resulting compound will be, already we have HCOH and CH2OH. Now to this carbon, one OH is there and one CN is there. So this could be one of the product, or the OH can be on the right side and this H can be on the left side. That is the another compound. So these two are the compounds. So this is the compound which I have drawn here. And this is one more compound where OH lies in the left side of the carbon. Okay. So we got the cyanohydrin. What is the cyanohydrin? CN and OH containing compounds are called as cyanohydrin, which are formed by the addition of this particular HCN to an aldehyde. Okay, it is a nucleophilic addition reaction of aldehyde. And then next one reaction with this H2 and H plus. So what is this actually? It is H3O plus, right? Acidic hydrolysis. So acidic hydrolysis of the cyanide group leads to carboxylic acid group. Okay, the cyanide group will be converted to COOH. This is the treatment of CN with H3O plus. Okay, so what is the third reagent? This is the third reagent, and the third reagent is with HNO3. HNO3 is the oxidizing agent. HNO3 is your oxidizing agent where it oxidizes only your primary alcohol. HNO3 will oxidize only the primary alcohol. So in this whole molecule, you can see that primary alcohol is present at the last position, okay, where the CH2OH is the primary alcohol. So it is getting oxidized to the carboxylic acid. The primary alcohols are oxidized to the corresponding carboxylic acids. Okay. So two products we are getting. This is the reaction, and we have to analyze these two compounds. Okay. So one compound is optically inactive and the other one is optically active. So let me discuss the optically active system and then come to this. Okay. So in the why we are calling this compound as optically active? Since it has two chiral carbon present in it. Since the compound contains two chiral carbon, what are chiral carbon? The carbon which is attached to four different atoms or groups, right? You can see these two carbons are attached with four different atoms or groups. So that's why the compound is called as chiral carbon. In case of this second compound, it is given that it is optically inactive. So why this compound is optically inactive? Because it has the plane of symmetry. Because this compound has the plane of symmetry. That is, if I cut this molecule into two, if I cut this molecule like this along this axis, I'll get two equal half, right? If I cut this molecule into two, I'll get two equal half. So which is also called as meso compound. It is also called as meso compound. So the meso compounds are optically inactive. Meso compounds are optically inactive. So that's why it is given like this. And what is the answer for this question now? And in both the products, one is optically active, the other one is meso product. So option B is the correct answer for this question. Option B is the correct answer for this. So do you have any doubt here in this question? You want me to repeat any part from this? Just let me know in the chat box. Otherwise, I'll move on to the next question. No. Thank you, ma. Thank you so much. I'll go for the next question, okay? So given below are two statements. One is labeled as assertion and the other one is labeled as reason. And the assertion is a solution of the product obtained by heating a mole of glycine with a mole of chlorine in presence of red phosphorus generates a chiral carbon. And the reason for this particular assertion is a molecule with two chiral carbons is always optically active. So in the light of the above statement, you have to choose the correct answer. So you can take 15 to 20 seconds for this question. Okay, and let me know the answer in the chat box. Just try to find out the answer very fast. Got the answer? Both are correct. Means which option you are saying? No, no, no. Both are not correct. So let me discuss the answer. Okay. So solution of the product obtained by heating of 1 mole of glycine. So what is the formula for glycine? It is CH2, COH and NH2, right? So this is called as glycine. This is called as glycine. So it is treated with chlorine in presence of red phosphorus. Okay. And what is the name of this reaction? In aldehydes, ketones, and carboxylic acid lesson, you might have studied this reaction. So this reaction is called as HVZ reaction. So in HVZ reaction, the alpha carbon, the alpha hydrogen will be substituted by the halogen, right? So the ultimate product will be one of the alpha hydrogen getting substituted by chlorine and COOH remains same. So this is the product. And in this product, you can see the central carbon, that is alpha carbon is the chiral carbon, since it is optically inactive or active, and as it contains 4 different atoms or groups around it. So one is NH2 and the other one is chlorine, third group is hydrogen and fourth group is COOH. Okay. So we have one optically active carbon or chiral carbon in the product we got from the given reaction. Okay, this is the concept. Now you check with this. So assertion is correct. So the reaction generates a chiral carbon, it is correct. But in the reason, a molecule with 2 chiral carbon. So how many chiral carbons we are getting? We are getting only 1 chiral carbon, no, which is optically active. Since they have given 2 chiral carbon, the reason is false. Okay, that statement itself is wrong. So the correct answer option would be A is true, but R is false. A is true, but R is false. Clear? Shall I move on to the next question? Yes. The incorrect statement regarding the enzymes is the incorrect statement regarding the enzymes is enzymes are biocatalyst. Like chemical catalyst, enzymes reduce the activation energy of bioprocess. And enzymes are polysaccharides. Enzymes are very specific for a particular reaction. So what is the answer for this question? What the answer? Option B? No, option B is not the answer. The correct answer is option C. Correct answer is option C. So enzymes are actually proteins. Enzymes are actually proteins of a high molecular mass. Okay, they are not polysaccharides. Polysaccharides comes under carbohydrates, right? So enzymes are not carbohydrates. Enzymes are actually protein molecules. Okay, that is the incorrect statement. Like chemical catalyst, like metal catalyst, which we are using in our organic reactions, like all the D block metals we are using as catalyst. No. So what is the work of this catalyst? What is the job of this catalyst? It increases the rate of the reaction by lowering the activation energy. The same job this enzymes also does, because they are the biocatalysts which are doing actions in a biological process. Okay, so they are biocatalysts. They reduce the activation energy and they are very specific. All these points are given there in our notes as well as in your book. Okay, the only incorrect statement is they are polysaccharides. Got it? Yes. So coming to question 6. Which of the following is a water-soluble vitamin that is not excreted easily? Which is the water-soluble vitamin? All the vitamins which you can see in the options are B group complex only, but there is an exception, right? Which are not excreted easily. All the B group and C group vitamins, they are excreted through urine so easily except one. So what is that one exception? What is that one exception? It is vitamin B12. It is vitamin B12. Okay. So that is the exceptional case under B group vitamins. Got it? Samruddhi, is that clear? Shall we go with the next
Yes, ma'am.
question? Yes, yes. Thank you, sir. Thank you, sir. And coming to question number 7, which of the following is not an example of fibrous protein? Which of the following is not an example of fibrous protein? So we have two different types of proteins, right? Fibrous protein and globular protein. So under each case, we have examples also. So which is an example for fibrous protein? So the answer is albumin. Albumin is an example for fibrous protein. Okay. So on the basis of their molecular shape, so proteins are classified into two. On the basis of their molecular shape, they are classified into two. One is fibrous protein, the other one is globular protein. So, and there are some informations related to these two also. So, fibrous proteins, they are uh, they run parallelly, and here they coil. Okay, they coil around to give a spherical shape. And here fiber-like structure, and here under globular it is spherical shape. Fibrous proteins are insoluble in water, and globular proteins are soluble in water. These are the concepts. So under each case, the example for fibrous is keratin and myosin, and the example for globular is insulin and albumin. Okay. So the correct answer, which is not an example for fibrous protein, is albumin. Okay, from the given option, which is option B. Okay. So is that clear? Samruti, is this clear? So I was
Yes, ma'am.
discussing. Yes, I was discussing about this question. Okay, fine. So coming to the question number 8, the correct representation in six-membered pyranose form for the following sugar. So this is the sugar given to us, and we have to find the six-membered pyranose form of this particular sugar. So what is the answer? What is the answer? The answer is, what is pyranose? What is pyranose? Yes, pyranose means the cyclic structure of the glucose. Pyranose is the cyclic structure of your sugar molecule, especially the 6-carbon containing system. Okay, so that is called as pyranose. Okay, I'll tell you. Now here all the 6 carbons are in a straight chain manner. All they are present in the straight chain format. Now, if I make this as a cyclic system, so this particular oxygen, it will go and attack this carbon. Okay, it will go and attack that carbon, and the electrophilic, the nucleophilic substitution occurs, and I will get a 6-carbon ring. Okay, and I will get a 6-carbon ring. Okay, so let me take this as carbon number 1, 2, 3, 4, 5, and 6. So now there is a linkage between carbon and oxygen for first carbon and fifth carbon because of this attack. So due to this, I am getting a 6-membered ring. So this is considered as 1, and this is 2, this is 3, 4, 5, and 6. So I am getting a 6-membered ring, right? So that is called as the pyranose of the particular sugar. And now you have to see the groups which are present on the left side and right side of this carbons. And to the second carbon, the hydrogen is present on the right side. So the groups which are present on the right side, they have to come in the bottom position of your cyclic system, which is your pyranose ring. Okay. So here the carbon number starts from here. This is carbon number 1, 2, 3, 4, 5, and this is 6. The same way here also. 1, 2, 3, 4, 5, and this is your 6th carbon. So same way you have to give for all the systems. Now, how will you find out the correct answer from this given? I told you the groups which are right to the carbon, they have to occupy the bottom position. Okay. So accordingly, you apply this concept and let me know the correct answer in the chat box. Let me know the correct answer in the chat box. Option A. Option A. Check once again. Check once again. So this is our carbon 1. This is 2. This is 3, 4, 5, and 6. Okay. And for both second carbon and third carbon, hydrogen is present in the right side. So they have to come to the bottom side. So check once again. This is the correct answer. So in case of option A, only for second carbon, hydrogen is at the bottom position. But for the third carbon, you see OH is there. So it is not the correct answer. Which is the correct answer? Yes, good. Option D is the correct answer. So this is your correct answer. Okay. And here also OH you can see. But for the last before carbon alone, the last before carbon alone, you have to interchange. OH, the right side group has to come to the top position and the left side group has to come to the bottom position. Basically, this OH forms the bond with this carbon, no? So you just consider this hydrogen alone, which is there at the left, and put that left group in the bottom position for this fifth carbon. Okay. So option D is the correct answer for this question. Good. Now coming to the next question, question number 9. Which of the following is a basic amino acid? Which of the following is a basic amino acid? So we have 3 different types of classification, right? Acidic, basic, and neutral. You have to tell me which is the basic amino acid. Which is the basic amino acid? Option C. Okay, let's check. So you can see something on the slide. Acidic, basic, and neutral amino acids are given to you. And we have 4 basic acids. They are arginine, histidine, and lysine. So you gave option C, lysine, right? So that is the correct answer. We have only 2 acidic amino acid, which are aspartic acid and glutamic acid, and 4 basic, that is arginine, sorry, 3 basic, arginine, histidine, and lysine. Okay, lysine is the correct answer. Good. That is the basic. The remaining things are neutral. So moving on to question number 10. Given below are 2 statements. Maltose has 2 alpha D glucose units linked at C1 and C4, and it is a reducing sugar. And they have 2 monosaccharides called alpha D glucose and beta D glucose linked at C1 and C6. And it is given that maltose is a non-reducing sugar. You have to choose a correct answer. Take some minutes and take some seconds and try to get the answer, which is correct. You get the answer? In first statement, they are saying that it is a reducing sugar, and in second statement, it is given that it is a non-reducing sugar. So obviously, option C is the correct statement for this question. Okay? Statement 1 is true, but statement 2 is false. I'll discuss the structure of maltose with you now. Just look into it. So this is the structure of maltose, okay, which is made up of alpha D glucose and alpha D glucose. So the carbon, one of your first molecule, forms the glycosidic linkage with the carbon 4 of the second alpha D glucose. So C1 of the first bonds with the C4 of the second. Okay. And this maltose is a reducing sugar. Maltose is a reducing sugar. Got it? So now you can relate it from the given statement. So maltose has two alpha D glucose, which are linked with C1 and C4, and it is reducing sugar, which is the correct statement. And these units are wrong for maltose, and non-reducing information is also wrong. The connectivity information is also wrong. So statement 1 is true and statement 2 is false. Clear? Shall I move on to the next question? Yes. We have any doubt here, Samriti? Shall I go with the next question? Okay.
Yes, ma'am.
Okay. So question number 11, sucrose on hydrolysis gives. Sucrose on hydrolysis gives. So two options are same here. So this is actually alpha. Okay, this is actually alpha. So option B and D looks same. No? So sucrose on hydrolysis gives. What is the answer? When you hydrolyze the sucrose, you will get alpha D glucose and beta D fructose. Okay. Sucrose on hydrolysis gives alpha D glucose and beta D fructose. Got it? Okay. I'll go with the next question. Question number 12. The non-essential amino acid among the following is. The non-essential amino acid among the following is. Which is the non-essential. Two classifications are there. One is essential amino acid, the other one is non-essential amino acid. You have to tell me. Just non-essential. So all these are just your informational related questions only, nothing to do with the concept. So if you would have memorized the essential and non-essential amino acids, you would have answered this. Okay, I'll show you. Alanine is the correct answer, which is non-essential. So you can see the essential and non-essential list here on the screen. You can take a screenshot. You can take a note of that. You can just you memorize. There are 20 amino acids. Among 20, 10 are essential and 10 are non-essential. Okay. So you just read the any of the 10. Just to memorize the 10 amino acids of essential, or you can do with the non-essential. So that it will not get confused. Okay. You can see alanine is coming under non-essential. The other three, lysine, valine, and the leucine, they are essential. Okay. Clear? Yes. So I'll go with the next question. That is question number 13. The difference between amylose and amylopectin is. Difference between amylose and amylopectin. So where do we study these amylose and amylopectin? They come under the polysaccharides, right? Under the starch section, that topic, you will study about amylose and amylopectin. So what is the answer? Answer would be option A. I'll show you why option A is the correct answer. Okay. So let me discuss some information about the structure of starch with you. So starch is a polymer of alpha glucose. Starch is a polymer of alpha glucose. And there are two components of starch are there. One is amylose, the other one is amylopectin. And we got question from these only, two only. And amylose is an unbranched chain polymer of alpha glucose, and it contains C1C4 linkage, water soluble in nature, and 15 to 20% of starch is there. Okay. And amylopectin is a branched chain polymer. It has C1C4 linkage and C1C6 also. It is linear as well as it is branched. And it is insoluble in water. It constitutes 80 to 85% of starch. So the major portion is occupied by amylopectin and only 15% is occupied by, is constituted by amylose. Okay. So you have to see. We got the question from this linkage part. In amylose, 1,4 linkage. In amylopectin, 1,4 as well as 1,6 linkage. Got it? Now I will come to the question again. So the difference between amylose and amylopectin. Amylopectin have 1,4 alpha and 1,6 alpha. Okay. Amylose have only 1,4, not 1,6. Amylopectin have 1,4 alpha, 1,4 beta. It is not beta, it is alpha, right? So it is also wrong. Amylose is made up of glucose and galactose. No, they are the polymers of just only the one sugar, which is alpha glucose. It is not galactose. So option A is the correct answer. Clear? Samruddhi, is that clear? Shall I go for the next question? Yes. Which of the following compounds can form a Zwitter ion? Which of the following compounds can form a Zwitter ion? What is a Zwitter ion actually? What is a Zwitter ion? What is a Zwitter ion? Zwitter ion is the system or the compound which has both positive as well as negative charge in it. Okay. So you can see 4 options on your screen. And option A is aniline. What is aniline? C6H5. NH2 is aniline. Acetanilide. So let me draw the structure for you. The acetanilide is just a second. It is actually NH. Okay. So there is an amide linkage here. NH, C double bond O and CH. This is your acetanilide. And the benzoic acid is C6H5 COOH, right? And the glycine is CH2 COOH and NH. So out of these 4 compounds, which one will form as Zwitter ion? A compound should contain both basic group as well as acidic group in it. Then only it will form as Zwitter ion. In case of aniline, you see only basic group, that is NH2 group, only is present. So aniline will not form. And coming to acetanilide, this is your amide linkage. This is your amide linkage, where CONH, both together they are acidic in nature. They are electron withdrawing in nature. Okay, so it will also not form. No acidic hydrogens are there. And here, benzoic acid, you can see only acidic group is present, no basic group. But in case of glycine, we have acidic basic group as well as acidic group. The lone pair which is present on nitrogen, it will go and attack this hydrogen and the electrons are shifted to oxygen. So what we will get? We will get NH3 plus CH2 and COO minus. So in this molecule, We have both positive and negative charge located on it, which is called as Zwitter ion. And all the Zwitter ions are neutral. Since they have equal number of positive and negative charges, they are neutral in nature, and also they are amphoteric. Zwitter ions are amphoteric. Amphoteric means a compound which can act as an acid as well as a base. Okay, you can treat this compound with acid as well as a base. So that is a Zwitter ion and its related informations. So the correct answer is glycine. Glycine is capable of forming a Zwitter ion. Clear for all? If you have any doubt, you can let me know the doubt in the chat box. Shall I go with the next question? Question number 15 for today's class. So the stability of alpha helix structure of proteins depends on the stability of alpha helix structure of proteins depends on. So the alpha helix comes under the secondary structure of protein. Okay. So the structure of proteins can be studied using 4 different point of view. One is called as primary structure. The other one is secondary structure. The third is tertiary structure of protein. And the fourth one is quaternary structure of protein. So the secondary structure is again classified into 2. One is alpha helix. The other one is beta pleated sheet. The other one is beta pleated sheet. Okay. So in alpha helix, you can find the right-handed screw kind of folding of polypeptide chain. And in case of beta pleated sheet, there will be a sheet-like system. Okay, you will get a sheet-like system. So here, we have all these are made up of amino acids. All proteins are made up of amino acids, right? So all these are one amino acid present here. So now, how this particular amino acid is connected with this amino acid? There should be some force of interaction between two, right? Now here in this question, they are asking you that particular force of attraction which stabilizes that particular compound, alpha helix. Which stabilizes the alpha helix? The interaction is stabilizing. So what is the name of that interaction? So the alpha helix interaction is hydrogen bonding. Hydrogen bonding is the only interaction which stabilizes the alpha helix. Okay. Got it? So the answer is hydrogen bonding interaction. Clear? Any doubt? If the question is clear to you, can all of you or any one of you type yes in the chat box? If anybody is having any doubt, you can ask me. I'll repeat. If everything is clear, then type yes in the chat box so that I can understand. The concept is clear to you. Yes? Yes, Hitashri, thank you so much. It is clear to you. You have joined late, it seems. Now only I am seeing. Okay. Okay. So now, moving on to next question. The formulas of A and B for the following reaction sequence are. The formulas of A and B for the following reaction sequence are. So a reaction is given to you on the screen. You have to do the reaction and find out the formula of compound A and B. So I'll give you some 30 to 45 seconds for this question. Just try to get the answer and let me know the answer in the chat. Okay. Has anyone got the answer? Fructose on reaction with HCN. Fructose on reaction with HCN, what happens? So, see the solution, all of you. So, this is your fructose molecule. This is your fructose molecule where the formula is C6H12 and O6. So, this is the formula for fructose where we have the ketone group in the second carbon, second position. Okay? And this fructose is reacting with HCN. So, it forms cyanohydrin. Break the bond, add H2 oxygen and Cn2 carbon. You'll get a cyanohydrin. And cyanohydrin on acidic hydrolysis. So during one of the question only I told you, no, cyanohydrin on hydrolysis forms carboxylic acid. Cyanide group will be converted to COOH group. And this compound has the formula C7H14 and O8. Okay, this is compound A. And the same fructose on treatment with sodium borohydrate. What is the sodium borohydrate? It is a reducing agent. Sodium borohydrate is a reducing agent, but NaBH4 with Hi and phosphorus with hydrogen iodide, the 6-carbon containing molecule will be reduced to a 6-carbon containing alkane. So what is the name of the 6-carbon containing alkane? It is hexane, right? Hexane has formula C6H14, CnH2n plus 2. This is a general formula no, for alkane. N value is 6 here. So the answer will be C6H14. So which is the correct option? Option A. Option A is the correct answer. Clear? So I'll go with one more question for today's class. And the question is, the correct statement regarding RNA and DNA respectively is. This is one of the very easiest question of this class. You can get the answer so quickly. Can you let me know the answer in the chat box? You've got the answer, just type the answer in the chat box. The correct statement regarding RNA and DNA. So all the statements are related with the sugar molecule present in RNA and DNA, right? So in case of RNA, it is ribose. The name itself is ribonucleic acid, right? And DNA is deoxyribonucleic acid. It is ribonucleic acid, and this is deoxyribonucleic acid. Just check for it. Arabinose is not the sugar. The sugar is actually the ribose sugar. You can find the ribose sugar for RNA in option D. And DNA is deoxyribose. So the correct answer is option D for this question. Okay. Clear for all? So I want to go with the last question for today's session. That is the structure of protein that is unaffected by heating is. The structure of protein that is unaffected by heating is. So while heating, only the secondary structure, tertiary and quaternary, they get affected. Primary structure remain intact. Okay. So the answer is primary structure. The primary structure is unaffected by heating because in primary structure, you can see all the amino acids connected in a linear fashion. Okay, there is no interaction. So even if you heat it, no bonds are going to get disturbed. So it remains intact. But in case of secondary and tertiary, so the bonds, the hydrogen bonding I was discussing, no, those hydrogen bonds and the van der Waals force will be there in the tertiary structure, and sulfide linkages are there. Electrostatic force of attractions are there. So these types of forces and linkages, they are present in secondary, tertiary, and quaternary structures. So they get disturbed on heating, on heating it to high temperature. They get broken down. but primary structure is not affected as it doesn't contain any types of interactions. Got it? So I hope the question is clear to you. And if you have any doubt, you can ask me now. If you have any doubt, you can ask me now. Otherwise, I'll meet you all in the next class. Okay? I'll give you some 15 seconds. If you have any doubt, just put it in the chat box. I'll clear it. If there are no doubts, I'll meet you in the next class. So no doubt. Okay. Okay. Thank you, students. Thank you so much. Take care. I'll see you in the next class. Thank you very much for listening to the class. Bye-bye.